Hello everyone, welcome back to the graph series, and in this video lecture we are going to learn about the breadth first search, that is a BFS algorithm. It's a graph traversal algorithm which systemically explore all the vertices, right? So it begins with the root node and explores all the neighboring nodes. So it uses the breadthward motion, and it is particularly useful for finding the shortest path in the unweighted graph. So if we consider for the weighted graph, we have Dijkstra's algorithm and rest of the algorithms. But for unweighted graph, if we want to find the shortest path, then we can use this BFS algorithm. Now, how it works? So, I'll explain you with example. So, let me have one graph. So, this is a directed graph but not weighted one, right? So I'm taking one graph and these are the directed one, and what we need to do is we need to find the traversal using the BFS. There is one more method that is called depth first search, DFS. I'll explain you that in the next video lecture. So let me have some more vertices, and one more. Okay, I think that's enough, right? So basically we need to choose the starting vertex, so it can be a root. See, this is a graph, right? So you cannot have that this is root, or you cannot identify because it contains a cycle, right? So you need to choose your starting vertex, right? So that start vertex you need to choose, right? Usually it can be anything, but normally we start with this, that is A. So this A is my starting vertex. Now what we need to do is we need to maintain one queue, that is for maintaining all the neighboring nodes, right? And we'll have one visited, this is also queue. So in that we are going to maintain what are the visited node, right? So I'll write it over here, this my queue, and then I have one more queue, that's a visited one. And step by step I'll explain you. So let us start with, so we are starting with vertex A, right? So what I need to first do is I just need to enqueue that A into my queue, right? This is the initial stage, right? So in an initial stage, whatever starting vertex is there, I need to just enqueue that starting vertex inside the queue, right? This queue, right? Not the visited one. Now next what I need to do is I need to just dequeue this A, right? I need to just dequeue this A. See, as soon as I enqueue that A, so my front is here as well as my rear is here, right, in this queue. But next what I am doing, I need to just dequeue this A, but along with that, before dequeuing it, I need to enqueue all its neighbors, right? So let me just have it over here, that the adjacency list. So for A we have B, C and D. See, if you are listing it out like this, then it would make it easy for you. For B we have E, for C we have B, and for C we have B and D. Then for D we have G. For C we have B and D, yeah. For E we have F and even C. For F we have C, then H. For G we have F, we have H, and we have I. For H we have I and E, so E and I. And for I we have only F, right? Just will check it once again. So yeah, for D we have G only. Okay, that's fine. Now what I need to do is I need to push these neighboring nodes of A in this queue. I need to enqueue it, right? So I am enqueuing this B, then C, and then D. So my rare will shift from here to here. Here I am having my rare, right? And I need to dequeue this A, so my front will be here, right? And then I am pushing this A into my visited list, right? So I have visited, I'll just mark it over here that I have visited this A, right? Now again we need to repeat these steps only, that we need to dequeue it, right? This queue we need to dequeue, right? So dequeue is from front, and before dequeuing that particular element we need to enqueue all its neighboring node into that particular queue. So now it's a turn for B. So B is having only one neighboring node, that's E. So we'll just enqueue this E. So now my rare will shift from this to this, right? And I'll just dequeue this B. So, and I'm inserting and queuing it to my visited one, right? So now I have visited this B and its source is A. So I'm just having this double line over here. So it would be, you can easily recognize it, right? Now next it's a turn for, now my front will be here, right? So now what I need to do, you might be knowing it, right? It's quite easy. You just need to enqueue the neighboring node of C, so that is B and D, right? So what we'll do, we'll add B and D, but before that we just need to check that whether this B and D are already there in a queue. You need to check that. If it is already in a queue, so you need not to add it again, right? So if you can check that B, so B is already visited, right? If you check D, D is already available into the Q, right? D is available over here. So no need to NQ anything, right? So you just DQ this C and NQ it to the visited, right? Now my front will shift from this to this. I have visited C, so I'll just mark it over here that I have visited this C, and that is also from A, right? From A only I'm visiting this, so I'll just make it over here. I just darken it. Okay. Now next it's a turn for D, right? So you just need to search that what is the neighboring node, that's a G, and it is yet not processed, right? So you just need to enqueue this G here, right? So this rare will shift here, and now we need to just dequeue this D, right? And enqueue it into the visited one. So we have visited this D, and again the origin for this D is A only, right? So we have visited it via this, right? Now next what is next? This front will be shifted. Now if I dequeue it, so front will be shifted over here. Now it's turn for E, so we need to find the neighboring node of E. So for E we have F and C. None of it is available in the queue, right? So we simply enqueue it. So I'll make it in alphabetical order. So first C and then F, right? So your rare will be shifting from this to this, right? Now you are dequeuing this E, right? And enqueuing it into this visited one, right? And my front will shift from this to this. Now you have visited this E, but the origin for this E is B, right? So this E is visited now, and its origin is from me. If you cannot remember the origin, then you can maintain one separate queue for maintaining that origin, that from which origin we are getting through that particular node, right? Okay, now again we need to repeat the same stuff, right? So now it's a turn for G, and the neighboring node for G, that is F, H and I. F is already available into the queue. H is not available, I is not available. So again I'll enqueue H and I over here. So now my rare will be available over here, right? Okay, now I'll simply dequeue this G and enqueue it in my visited one, right? So now G is visited, and if you see, then the origin for this G, what can be the origin for this G? Are you aware of what can be the origin for this G? Yeah, here we have the origin that is D only. So from D we are coming to this G, right? Now next it's a turn for C. C is already visited, right? We need not to push it over here. That's a mistake. We need not to push it over, enqueue it over here, right? So that mistake I made, you be careful, do not make that mistake, right? Okay, So next I have F, right? So F, so we simply need to search that F. For F we have C and H, both are visited, right? Both are already available into the queue, right? H is yet not visited, but it is available into the queue, right? So need not to push it, right? So we'll directly, what we'll do, that will dequeue this F and enqueue it in the visited one. So we have this F over here and my front will be now here, right? So I'm visiting this F, and the source, the origin for this F from which we are coming to this particular node, that is E, right? So we'll go this, right? Okay. Now next what we have, that is H, right? So H is having E and I, both are already available into the queue, so need not to enqueue it, right? So we'll simply dequeue this H and mark it as visited. So H will be available over here, right? And then this H will mark it as available, and it is coming from F, right? Its origin is no, it's G. Its origin is G, right? So it's coming from this G, right? Okay. Now next, this my front and rear both will be pointing to this only, right? Then I is having F, that is already visited, right? So we'll simply enqueue it over here and we'll dequeue it from this. So now my queue is empty, so my front and rear will point to -1. This I'll make it as visited, so this is visited and origin for that is also G, right? So in this way we have got the traversal and the finally BFS tree. If in examination, if some, this is a visited structure, right? In which way you visit it? So it's A, B, C, D, E, G, F, H, I, right? And if someone tell you to draw the BFS tree, so it's A, B, C, the way we highlighted and that, so D, then E, then we have F, then we have G, then we have H, and then we have I. So yeah, that's it, right? So I hope you understood this BFS algorithm, breadth first search algorithm, and it goes level by level, right? So it traverses level by level, and we need to have one queue that is for dequeuing the visited node and enqueue it in the visited queue, and we need to enqueue all the neighboring nodes of that particular vertex that is dequeuing, right? So yeah, this is your sequence and this is your BFS tree, right? So I hope you understood it, and in the next lecture we'll learn about the depth first search, that is DFS algorithm. So thank you for watching this video.